All right, yeah, we're good.
Thank you for everyone who came out tonight. There's the attendance QR code in the bottom right corner, so you can get marked for being here. We also have the attendance code that's in the chat. Just to look ahead for what we have coming up, we have the Department of Homeland contractor Kyle Snyder. He's going to be coming and talking to us, as well as the AIAA president, Dr. Hassan. He will be coming as well. So we have a pretty good slate looking forward for the next few weeks. Tonight we have Mike Hamel with us. He spent most of his time in the Air Force working on the space programs and operations before going into the private industry, working as the Vice President of Commercial Space at Lockheed Martin. So without further ado, Mike, the floor is yours.
Great. Oh, thanks a lot, Josh. And Carissa, likewise, appreciate all that you're doing to keep this organized and on track. I appreciate the introduction, and probably more than anything, I appreciate the opportunity to just get together. I regret a lot that we're not able to do this face-to-face. I suspect that you all would prefer to be doing this face-to-face also. There's no replacement for that kind of contact. Part of the reason I like doing this is that I actually probably learn more than you all do. That when you're many years removed from sort of what's happening with the new generation of engineers and young employees and the rest of that, it's really good to get kind of refreshed and up to date on what's going on. So I'm hoping that this doesn't turn out to be a monologue on my part. I just soon it'd be a dialogue. And quite frankly, at any point you got any questions, so just dive in or let Josh know or whatever else, because I'm serious. I really would like this to be a dialogue. So a little bit of personal things and the rest. I'm relatively new to North Carolina. I and my wife relocated from Washington, D.C. a couple of years ago when I retired from Lockheed Martin. So we're new to the Triangle area. I did have a chance in 2019 as part of AIAA to visit NC State, and quite frankly, I was blown away. I had no idea that the engineering school was as big as it is there. And so, and by all accounts, it's a very, very capable school. And so, congratulations to you. I know it's a tough program overall. And I will tell you that with all the other challenges that you all have got going on and the rest of that, all I can say is keep plugging at it. You all chose to take the hard problem. You didn't take any of the sort of liberal arts. You dove right in and took all the hard classes, and you have to study and do projects and deliver. So that says a lot about your grit, and I can assure you that will pay off in the years ahead overall. So let me maybe expand a little bit to just give you a little bit of sense of where I come from, my experience and the like. As Josh said, I spent my entire professional career in the space business. I almost hate to say this, but I'm now right in round numbers at 50 years of experience in the space business. And so you start asking yourself, well, gee, did we even have satellites back then? And the answer is yes, but only for a few years before I got involved in the business. I was as a young teenager, I was growing up in the 60s, sort of inspired by Apollo and a lot of other things going on. And like tens of thousands of other young people, engineering was the thing that I wanted to go off and do. But as it turned out, like I suspect many of you too, that sure needed to find some place where you could get somebody to pay for your education, as opposed to trying to figure out how you're going to do that. And I was fortunate, and I got an appointment to the Air Force Academy, and quite frankly, it had a pretty good engineering program there. It was something I wanted to do, and so that was the path that I headed off on. Unlike though the vast majority of my classmates that wanted to go into flying. I enjoyed flying, but I really wanted to use my engineering skills. And I learned that there was a pretty sizable military space program even back in the 1960s. And through by hook and by crook, I was able to start off as a young lieutenant working in the space business in the early 1970s. And unlike, and you're going to hear me talk a little bit about what some of my thoughts about career paths that you might want to pursue and the rest, I did exactly the opposite of what I'm going to recommend to you. And that was, I think it's really important to get hands-on experience and expertise in some technical fields where feel like you've mastered something. I, by contrast, because in the military, there's very little that we actually build ourselves. And most government high-tech fields, the government itself does not build very much, but it actually invests a lot in industry and in academia. And so the nature of what we typically do is working a lot, as I say, with industry and universities and researchers and the like. And I started off very early in getting to work on big ideas and concepts. And as I talked with Josh, one of these things that you reflect back on, you never would have guessed it at the time, but I literally worked the very first selection of the contractor that built the first GPS satellites. And so from the inception of GPS, I've kind of watched over its many decades of evolution. And one thing I can say is that nobody at that point in time had any idea about how profound and world-changing GPS was going to become. We thought it was just going to be something different than LORANs and TACANs and things like that. And lo and behold, it's become kind of the global synchronizer for the information revolution. I likewise had the opportunity as a young engineer and officer to get involved with the space shuttle program, although that was a NASA program. But back in that time, that there was a decision by the nation that we were going to all the government and commercial launch to space was going to be done by the space shuttle. So we in the military and the Air Force had to become deeply involved in using the space shuttle for launching all of our operational satellites, our experiments and the like. And so I spent quite a number of years working very closely with NASA on the integration of payloads into the shuttle and, as I say, experimentation on orbit and the like. And so I got to know NASA pretty well, and also the whole process of launching things. Had the opportunity to then spend some years working in satellite operations at a ground station where 24/7, 365, you're performing critical operational missions. And so you start seeing kind of the impacts of stuff that got designed in and engineered in, but how then it actually operationally works overall. That was about my first 10 to 15 years of kind of doing that hands-on technical work. And then is typical with a lot of government, I think you'll find this in industry too, after you kind of establish your own technical and program kind of skills and the rest of that, they're kind of looking for that mid-career to be able to branch out and to move into other kinds of related fields and activities. And in the case of government, a lot of what that translates to is sort of program development, defining, getting the budgets for it, defending it with Congress, planning for how it's going to be operationally employed and the like. And so I spent quite a few years in my mid-career sort of being a staff person, pushing a lot of papers, but it was really an important set of experiences to understand how the federal government works. And likewise, how do you go from sort of specific technical projects and activities to much larger scale programs? And how do you then work between government and industry and trying to actually get moving forward with developing building capabilities? My latter years as a senior person, I just had a wealth of great experiences and opportunities. I actually got a 2-year stint at the White House working on national security issues in the vice president's office. Was able to lead up the Air Force's space operations and then development and acquisition my latter years. And so about 3/4 of my overall professional life was in the Air Force, and I got to do more things than I ever possibly could have imagined. Core to that, though, was that I actually worked a lot with industry over the time period. So as a result, I was able to see a lot and to develop some strong perspectives. But I did want to have a second career, and so I spent about 10 years in the private sector working for a couple different companies. I ultimately was the business lead for commercial space for Lockheed Martin. And in that role, and related things, got involved a lot with business strategy, business development, program management, finances, and also what's referred to as P&L, profit and loss. Do you make your numbers for your business? And learned a lot. As I like to say, I spent most of my life in the government where you're learning how to spend money. And once I got to business, everybody kept telling me, no, it's all about making money, not spending money. So I had to go through a little bit of a learning cycle on that overall. And now for the last couple of years, tried to stay active with consulting and advising on government and industry things that people have needs, and I find things that, interesting, if you will, so that trying to stay current and continue to be involved. And I would say with the recent creation of the Space Force and a separate dedicated DoD command for space, there's a lot of issues going on about the evolution of military space that able to hopefully continue to contribute, which is part of what I'm doing at Washington, D.C. right now. So it occurred to me as I was going through this, I mean, what is it that I might be able to talk to you all about that may be of some relevance and interest? And as I look back after all these years, you say, okay, so what is it about the engineering profession and the career paths? What is it that has been fulfilling about it and satisfying? As I say, I don't know what brought each one of you to this particular chosen path, and it certainly is not a lifelong commitment. But this is a big deal what you've chosen to devote your formative education to and rest. And what I'll tell you is that it's hard stuff. You know that you're going through it right now. You can't fake it. The equations and the laws of physics and the rest of that, they don't give in at all. So I mean, it really is something that requires attention to detail, abstract thinking, be able to deal with complex concepts and things like that. And so good on you all. But how do you translate that from what you've been taught and learning and through your projects and the rest of that into, well, what does that look like once you're actually in the workplace? And I guess as I look at this, amongst the most satisfying pieces for me have been when you're in engineering, you're working on hard problems. They're typically big problems. If they were easy or somebody had figured out the solution, they'd already been done and you'd move on to the next thing. So it is something where you're always going to be faced with challenges, unknowns, complex issues and problems. One of the things I would say that is really important, from what I've seen in education, both at the primary, secondary, but also in college, a lot more emphasis on team efforts. And that to me is really important, because those are foundational skills that are really critical. And there's a lot more multidisciplinary kind of approaches that are needed to deal with the problems and opportunities that we face in the future. So that to me is a really important set of skills beyond just the understanding the laws of physics and the techniques of engineering and the particular disciplines overall. But the other thing I'd say too is that there's almost continuous change of technology, or everything. Seldom is there completely stroke out of the blue, some radical new approach. Everything is an evolutionary adaptation, applying sort of known things, but now enabled by new technology to go conquer some new problem. And so it's a cycle of continuously changing technologies, challenges, and opportunities. And what that really means is that you can't just get your degree and then sort of pack it in and then expect you're going to work for 10 or 20 years. You really have to stay fresh. You have to be inquisitive about kind of what the next opportunities and steps are overall. And frankly, as I mentioned, a lot of this is multidisciplinary. Even on project teams, you're going to have, and again, if we were able to be sitting across the table and talking, I'd love to hear the kind of projects that you all are working on. But it is routine to in real world applications to have to bring together a diversity of different technical skills, whether it'll be computer and software related, or whether it's materials, or as dynamics, or if it's aeronautical platforms. I mean, there's new techniques of CFDs, the rest of that. So I mean, it's just dramatically different techniques and skills are needed. But then, sort of in a real world environment, you also have to then be able to bring in other aspects, such as the financial and the business related aspects. There's only so many dollars out there that you're actually going to see that will be made into sort of open-ended research and the rest of that. A lot of this is something that has to actually be for a in purpose. And in the case of business, it better be able to make a profit, or you're not going to be working on that very, very long overall. So these are all diversity of skills, both technical as well as other kind of team sorts of skills that I think is really important. And every one of them is critical to the success overall of the of whatever project that you're actually working in. I would say that again, from my perspective, and I really wish we were able to get a little bit better acquainted, but the limitations of time here are likely not to permit it. But I would really like to understand a little bit more what kind of engineering specialties, where you all have been working both in class and where you're hoping to go overall. But what I would say is that from my vantage point, I'd say this is not only from my government time, but also working in industry, is that there really are limitless opportunities. Now, it may not seem like it from where you sit right now, but it's really fascinating. And frankly, what you're doing of being affiliated with AIAA is you start getting a glimpse of what are some of the very diverse things that are going on. And that includes industry, academia, in government, and what's sort of the cross interconnection between those different sectors. But there's another part of this too, and that is sort of the life cycle of any system or program. And it goes all the way from the early research and enabling technologies to the really tough engineering development to take some kind of concept and technologies and actually be able to engineer it into a useful product. But that's not enough. You actually have to be able to produce the product with some regularity, specificity, in many cases, hopefully at a profitable price overall. And then the other part is that you typically end up having to support these capabilities. I will tell you that some of the most challenging things that I had done over my career is we would have satellites that had perhaps been designed and built 20, 25 years ago, and you're trying to tell from a set of telemetry streams when an anomaly occurs what the heck happened. And so it is a forensics problem like you can't imagine overall, but it's that sort of thing where you have to be able to deal with a lot of unknowns with tenuous sets of empirical data, and to be able to make significant decisions about what do you actually do. And that's true with aircraft systems, certainly space systems, but other high-tech systems that you are likely to touch on overall.
So if I
talk a little bit here about then maybe kind of what does the future look like from my vantage point. Certainly my time in industry, that's where a lot of the pressures come relative to how do you efficiently and effectively design and build capabilities. And again, in many cases, hopefully for products that are going to actually be profitable in the marketplace. And there's just no question in my mind, probably the single biggest driver that we are seeing is that there's a digital revolution that's going on. We saw within the past couple of decades a real expansive use of computer-aided engineering. It started moving into manufacturing, but now it's across the entire life cycle, all the way from early concepts to modeling and simulation that then gets translated into detailed designs and even reaching out into supply chains where models and specifications are all handled digitally. In many cases now we're actually starting to see additive manufacturing and other approaches to being able to very cost effectively produce parts. But it doesn't end there. When you start then reintegrating and assembling flight vehicles, satellites, whatever, there's a lot of excruciating detail that goes into verifying and the procedures associated with it, and then the testing that has to go on to verify performance and the like, and then out through its life cycle. So today, one of the biggest things that is going on across the entire industry, and I say that in the maximum sense, has been the application of digital models and tools and techniques. And so I was only kiddingly talking a little bit about you all getting your merit badges in Zoom, and I'm sure a lot of what you're doing today. I guess Creole is one of the kind of the big tool sets and the rest of that, and I couldn't even spell Creole, but yet I would end up working with an engineer that could knock out design revisions or something in a couple hours and come back and with stuff that we would previously have to wait 2 weeks, 4 weeks, or whatever else to get design drawings and things like that. So you all are living in the midst of it, and frankly, what it's going to do is to make really going to magnify the value of each individual engineer, because there's so much broader set of things that can be done when you really are adept at the modeling and the digital tools, and to understand how these all link across the whole life cycle of any given system or product. So that's a really big deal in my view, and it's going to permeate engineering and aerospace in particular. The other thing I think we're going to continue to see a lot of drive, and that is the commercial marketplace. We certainly, I mean, if you take a look at the kind of the arc of history of the 20th century, the very beginning of it, Wilbur and Orville and some other people in other countries kind of proved the feasibility of powered flight. And you take a look at what happened in the sort of the decades that followed it, it was relatively slow, the development, but I would argue it was really World War II and the prolific use of aircraft in all manner of the conduct of the war. We had a huge aviation industry that after the war, all of a sudden is, well, what are we going to use that for? And commercial aviation became the thing that absolutely drove our markets. And this was all based upon now mass use of commercial transportation, whether that be for people or for cargo and all the rest of that. So you see in the aviation side, a real explosion that occurred in the 20th century. I think we're going to see similar things in the 21st century with space. And it's the confluence of not only lower cost means now to get into space, but it's also the micro miniaturization and the ability to pack more and more processing and capability in ever smaller packages. And so that kind of the continued drive for global markets and solving global problems are going to drive a lot of the space related technologies and programs and opportunities. And what's coming with this also then is really large investments in applied technologies. I think several of you said that you were likely going to seek employment in the federal government, and the federal government is a big customer of a lot of the products and output. But the other thing is the federal government still is a major investor in the basic research into some of the, whether it be materials, phenomenology, advanced devices and things like that. But it really then gets driven by the mass applications that occur with commercial products and applications overall. So I think that's going to be really important, and the pervasiveness of electronics and software driven elements in all applications are going to be a big deal. So I know you all are getting exposed to it, but having conversancy and competence in digital controls and software and the rest of that, I think, irrespective of what the actual field, whether it be aeronautics, astronautics, material, mechanical engineering, software and electronics are going to pervade all that.
So I had a quick question for you.
Yeah, please. Yeah.
So you sort of mentioned earlier how you went from working with the Air Force for about 10 to 15 years, then doing your mid-career, as you put it, which was a very different path, as more of paper pushing. And one thing that NC State does here that's really well is we have a senior design project, and there's a lot of different avenues with that. So like there's a design build fly, which is hosted by AIAA. We have a lot of members here in attendance that are on that team, Christian, Carissa, a few others that attend. And then there's the CubeSat, which is another senior design project, and I believe a firefighting UAV. So in your time through your career, how important is that design, taking that time to sort of get the details right versus going straight to a model, testing it, seeing how it does, and then going back to that drawing board?
Yeah, so I've seen a lot of this, and I had a senior design project project and the rest of that. And I'm almost embarrassed to look back at it now because it was sort of an individual effort. Didn't work out very well, but it was an important personal experience. What I see now is a lot of team design projects, and in many cases, it's multidisciplinary and the rest of that. And I think it is terrific because you start getting sort of a microcosm of all the elements that have to come together to actually produce a useful product or outcome overall. And that's the kind of thing that you're going to see. I don't care whether you're in government or industry or other research areas and the like. That's really the kind of work that you're going to have to do. And you have to learn the language of a lot of other disciplines, if you will. And a lot of this has to do with also respecting other disciplines. That every part of the team plays a critical role in the rest of that. And the sooner you start learning that and how to be able to communicate and work across, I think it's great. So, AIAA, I think that's one of the things that they do well is try to early on, kind of promote that kind of activity. So is that, so I think you were asking about the design thing. Design is really critical. I mean, if one was going to say, okay, of all the places that I've seen or been involved with and the rest of that, I would say that's right up at the top of the list of the most intriguing aspects, because you have to imagine things and then figure out how do you take a set of functional or performance requirements and the rest of that and translate it into something that's physical that can meet those requirements. I would say also, though, another aspect of the life cycle that's really challenging, and that is when you get to assembly, integration, and test, because that's the point. All this stuff decomposes from top level requirements. You got to figure out the individual gizmos and widgets and all the rest of that. But then when it starts coming together, all of a sudden you got to take stuff that was built in a lot of different places, and you wonder, what was that person thinking when they designed this thing? Because it doesn't fit, doesn't work. Why didn't they think about this? But then you're also stuck on the tail end of a program where you got a schedule and a budget, and you just got to get it delivered. So there's a lot of time pressure and a lot of things and innovation you got to go through in AI&T that is very challenging. And I say even operations. Again, the stuff I learned the best was when I had to operate something. Because again, you had to, if everything is functioning just fine, well, fine, it'll take care of itself. What happens though, if you have to figure out if there's an anomaly, a problem, or whatever else, you have to almost reconstruct the whole design and understand what are the symptoms and other things. So each one of the phases, I think, has a lot of intrigue. In general, design is really challenging and it's very satisfying. Does that kind of get, Josh, to your question? Or
Yes, sir, it did.
Oh, okay. Well, please, I'll go droning on here. So if any of you got a question or whatever else, please just just speak up or whatever else, because as I said, I'd prefer this to be a dialogue as we go through some of it. So again, kind of looking into the future, we are going to be facing really big challenges in this country and across the world as we look into further into the 21st century. You all live with it, you know it. There's going to be demands for clean energy, more efficient energy, climate change, big issues and deals there, transportation, the environment alike. And most of the solutions in those areas are going to come from engineering ideas and approaches overall. And so I think that is almost, as I say, unlimited. And I think that one of the things that's actually been over the past, say maybe a couple decade or two, there's been a newfound respect for STEM education and the criticality of what engineers actually do. There was a while where everybody kind of talked about the geeky engineers and all the rest of that, and it was obviously not terribly respectful. But then all of a sudden, you started ending up with lots of billionaires that came up with a better mousetrap and proved that indeed engineering is where new ideas come to life. And so there are going to be big challenges that are going to depend upon engineering solutions as we think about your years and careers ahead here. I think from a little bit closer to home, we really are entering sort of the second space age. I entered into the sort of towards the tail end of the first great space race with the March to Apollo and a lot of things like that. And we continue to build up incredible capabilities. Regrettably, too many of them are not well known, nor can we even talk about. But they have just sort of been very workmanlike advances. We're now seeing big investments with unconventional approaches, with self-made billionaires wanting to go colonize Mars and things like that. So there's a lot of excitement out in the kind of what we refer to now as the new space sector, and a lot of young folks are finding it very, very challenging from an intellectual and from a personal standpoint, and some of the things going on. It's what I refer to as kind of the new space age that's developing. And,
Oh, if I could interrupt you one more time,
please.
I'm
Yeah.
sorry.
No.
We have a question in the chat.
Sure.
Do you see a place for chemical engineers in the space exploration industry, since you have said that it's more of a cross-discipline kind of field?
Yeah, so absolutely. Interestingly enough, and I was going to talk a little bit further on here. It's very hard to chart from what the studies that you do and what expertise, where you're actually going to go and end up. It turned out in my latter years, when I was running the Air Force's Space and Missile Center, I had several colonels that were working for me, 4 of which had PhDs in chemical engineering. You go, huh? What would we be doing? Well, turns out that the essence of everything in space depends upon being able to convert chemical energy into velocity. And so there's a huge number of applications for maneuver, propulsion, other applications, life support, and the rest of that require a lot of skills. And oh, by the way, a lot of the techniques relative, we're advancing now with regeneration and things like that. So interesting enough, I was remiss in not bringing up chemical engineering, but it's highly sought after because it is one of the really critical elements of the space business. So, whoever raised that question, is that?
That was Abe who asked that.
Okay. So yes, we love chemical engineers.
I could actually ask another question really quick.
Please.
As somebody who's interested in the business side of things as well, are there any steps that you'd recommend that we take as engineers going forward into depending on where we are in our career type thing? I know a lot of people have gotten MBAs or, things like that later on. I know it's something that I'm interested in just because I find it super interesting. But are there any steps that you'd recommend from your experience with both of them?
So when I actually started my career in the Air Force, it became clear to me, I sort of knew this, but it became real clear real fast that everything we did, we worked with industry. Mm-hmm. And it really was important to understand the language of industry, what makes it tick. And so literally within, I think it was a year and a half of me going to work initially, it wasn't even that long, it was less than a year. I went off and started up doing a part-time MBA. Okay. Spent a couple of years doing that. And so part of my reasoning was I knew it wasn't going to get easier as I got older and more committed with family and things like that. So I said, get it done now. And so I think it's a good foundational tool to have, because almost irrespective of where you work, whether it's in the private sector, in the government, there are just business and finance aspects that are really important. And I think it's a fairly typical path. I certainly can speak from the aerospace sector, where a lot of folks will come in as engineers and project leads, designers, and the rest of that. And it's a natural path to then move into some kind of project and program management. And frankly, those are probably the most sought after individuals as people move up into the executive ranks, because it's really important to have a good technical founding, but then you also have to be able to operate effectively in the sort of the business part of the world. So I hardly recommend that. And that's not the only path, but as I say, I think there's a good synergy between technical and management education.
Was there anything that sort of helped you prepare for that management career from being in the Air Force?
Oh yeah, absolutely. I mean, So one of the things, I can't remember who, it was Carissa or who, about possibly going into a government job and before maybe seeking something in the private sector. And what I will tell you is, from my experience, is that typically for young people, opportunities in government are pretty ripe. Oftentimes what happens is that, one, you're not down, if you are working at the circuit level, unless you're doing actual government research kind of work. And so you oftentimes are going to have a lot more responsibility at an earlier stage in your career than you would typically in the private sector. You know, one of the things I had not quite appreciated until I gone to the private sector is it's a hard challenge for industry and some places in government to say, how do I create career paths where, if I attract the really best and brightest people, how do I retain them? And they don't want to just do the same thing for 20, 25 years or something. You've got to be able to say, how can you grow? You can grow in terms of either the specialization or the breadth of your technical skills, or you can move into taking on project management responsibilities, and with that, then potentially grow, or even move into actual business management roles and stuff. So that's one thing I'd absolutely commend to each of you. We don't have the same kind of job stability that we perhaps did decades ago, where you were with a company for life or with the government for life. There's a lot more mobility goes on, but that just means that you all are going to have to think about, how do you manage your own careers, and how do you lay the foundations with whatever jobs or series of jobs that you have that prepare you for sort of the next things or things beyond that you would like to be able to go do. And so I think I was going to talk a little bit about that in terms of careers here in just a second, but you've got to be in charge of your own career. The days of, as I say, spending 30, 35, 40 years in one company and it sort of has the path. Arguably one of the strongest, most hallowed companies was General Electric. It was known for being the company that when you hired on with them, you were GE for life. And if you worked hard and talented and ambitious and the rest of that, people just did extraordinary things. Where is GE today? Okay, so, but those are the kind of things that you have to be mindful and attentive. And I'll say a few more words about that here in a couple, if I could. One of the things I don't want to miss is that there's a real international component in interdependence. So people bemoan globalization and the rest of that, but it's a fact of life. And industry and technical and supply chain matters cross international boundaries all the time. And that's where US industry looks for market opportunities. It's a place where, in the quest for ever reducing costs of products, looking for reliable suppliers and the like. And likewise, you all live it day in and day out with a lot of foreign students that are learning the skills, and, oh, by the way, are in many cases are going to remain in the US and stuff. So international is another really big part of the business as we look forward. This is, industry is going to be doing this, governments are going to be doing it. And so that's another part that I think is important. And quite frankly, where I'm going with on this is developing some international skills, whether it be language or having some interest in histories or regions or whatever else, particularly if it relates to your particular skills or education or the business area that you, or the company that you might be working with, and the rest of that. So I would highly commend international, because it's going to continue to be a wave of the future overall. So let me turn here to some thoughts then about about careers and career paths and success and the like. What I would tell you, and I think I briefly mentioned this, and you no doubt have heard this before, there's no such thing as a deterministic pattern where you go A to B to C. You'll be amazed as you talk to more people how many of them will say, well, I never imagined I'd end up where I am today. And lots of times you find that things that you may have gotten your degree in, and the rest of that is not what you work on. I mean, I got an aero degree from the Air Force Academy, and I hardly used any aero. It was mostly astronautics and systems engineering skills I had to develop. So That's not at all unusual. And the other part of this is that there is no linear path. There's a multitude of different paths and combinations of experiences that are really necessary. And so I wouldn't ever say, oh, this is the one solution. There are going to be places where taking on big challenges, being part of a really large team. Well, you may have a small role on a large team, but you're getting to see the kind of problems that large teams can do. Or you could be working. You could be the big dog on a particular project or whatever, and you get to see different parts of what it takes to pull together a whole program. There's some people that tend more to being generalists, and others really want to be immersed in the technical details on a narrow topic or subject or phenomenology. All those things are important. But a lot of what it has to do also is then to figure out, okay, what really do you think you're good at? What kinds of things might you aspire? And you're going to see lots of people. And what I will say to you is it's important to study people that you respect and people that you would like to emulate, that you can learn from their career. Reach out, talk to them. I think AIAA, this is one of the best aspects of it, is to just be able to hear a little bit. You're not in a professor student or a boss worker kind of relationship. You're in just getting the sort of the best advice of people that you respect, and you'd like to know what lessons that they may be able to share, or advice that they can share. Let me see. The other part too is that I think it's really important to what did I do here? Yeah. I told you, you're not supposed to touch this stuff.
It looks good from our end.
Well, yeah, but I had my notes off on another screen here, so let me just go. As I say, I think that it's important to find out what you're good at, find out the things that you really like, sort of study from others what they have done, and then try to emulate and develop networks of relationships overall. And frankly, over a career, you're going to find that there are times to say, yeah, this just isn't going where I want it to go. I need other opportunities. And sometimes you're going to be confronted with, gee, do I need to make a big leap? And that's important to build the self-confidence that you can make the big leap, and to be able to have that kind of courage of your convictions going forward overall. Let me maybe just close off. I think one of the things that sort of looking back on, I wouldn't say necessarily I've had an engineering career. I had engineering education that I worked on technical and programmatic things through my entire career that required to have competence in the engineering aspects of it. To me, it's been very satisfying for all sort of the personal reasons, but there's other sides of it too, and that has to do with that you're making a difference typically on hard problems and problems that are important. One of the things that I spent altogether 36 years in the Air Force, and one of the things that was really unique about that experience, and I think other kind of government job, is that it's not a for-profit kind of motivation. Government employment is really about supporting a mission, and you being part of something that's much bigger than just yourself individual or even your small team. And so there's a real satisfaction around the idea of being able to make a difference on things that are important. Now, that does not take away at all from things that go on in industry, because that's kind of the heart of what it is that made America great, is being very effective with technology and effective business and the like. But that has a very different dynamic, as I learned as I got into the private sector. That I would just tell you, one of the things that you have to be prepared for is that today, in this day and age, that everything happens to be driven by the quarterly investor calls, and to meet your numbers in terms of revenue and profitability and cash flow and all the rest of that. So it's a very vicious beast, if you will, but it also drives a lot of terrific things that we all enjoy from in this country overall. I would say something else that I touched a little bit on this, but I really think engineering is a very much a respected profession. There was a while, as I say, there was a little bit of viewing it, oh, it's all a bunch of geeks and the rest of that. But I think as the information age has really overtaken the globe and the rest of that, I think there's a really a wide societal view that, hey, engineers do hard things and they really produce big results. And when you need something to get done, engineers are the ones that do it. And so just being part of a profession that that has that kind of reputation, I think is very satisfying. So let me just leave it there and see if there's some other questions or discussions you all would like to get into.
So we had another question in the chat from John Peterson. It was more of along the lines of, when you were in your career, was there anything that you saw that really stood out from people who were freshly entering the field, or anything you suggest for us to do while we're in college to make the most out of it?
Yeah, I will tell you, and I think that's a really good question. Something that I always was impressed by, and I always looked out for, who were the inquisitive young engineers and people, who were the ones that actually demonstrated some initiative and wanted to know what more they could do and the like. I think those are two kind of personal qualities that are really important overall. Doors open up when people show an enthusiasm around what they're doing. They want to take on more. I was just talking with had dinner last evening with one of my young proteges, if you will. And to me, I think one of the most important things is to bring an attitude that says, I want the hard problems. It's sort of like if you hear about what the philosophy is in law enforcement, the rest of that, they don't run away from gunfire, they run to gunfire. Same thing with firemen, they run to the fire, they don't run away from it. And I think that's just kind of an attitude that says, give me the hard problems. I really want to make a difference. And people notice that. And the other thing, and some discussions I was having today is related to military matters, but one of the things that you're going to bring in sort of your first 5 to 10 years, and the rest of that is you don't know what you can't do yet. And so there's a lot of people, after you've been in any kind of business or other environment for a while, you sort of figure out what it is that people think are okay things to say, do, propose, and the rest of that. You're going to have the opportunity initially to being unburdened by not knowing what you can't do yet. You're going to come up with things, and you shouldn't hesitate a bit, because that's what everybody depends upon. Fresh young minds is to challenge sort of the assumptions that after 20 or 30 years, it doesn't even cross your mind. So as I say, I would say enthusiasm, taking the initiative, being engaging, those are really important attributes, and it will unlock a lot of doors. Now, you got to be technically competent, but it's more than just technical competence. It's also about are you really seeking out and aspiring to let's say, take on the hard problems.
I have a question that kind of builds off that. Really, throughout everything you've talked about this evening, you've talked a lot about hard and difficult problems. So my question to you would be, what's an example of like one of the more challenging problems that you've had the opportunity to solve in your career?
Ooh, so let me give you an example of one. And I was actually on the opposite side of this. I wasn't the enthusiast on this. And it is SpaceX and Elon Musk. So since the beginning of the space age, I don't know how many of you may be astro kind of folks or whatever, but trying to deal with the rocket equation is a really hard problem. The amount of velocity you have to attain in order to escape gravity and the rest of that, and the mass fractions involved, it's just awful. But what ended up happening, everybody knew that the answer had to be, how do you get a high degree of reusability? You can't throw away hardware, all the expensive hardware, every mission and the rest, I'd ever expect to be cost effective or routine in the rest. So this has been sort of the holy grail since the beginning of the space ages. How do you get a high degree of reusability in space launch? And having worked on a number of those concepts, ideas, technologies for decades. I will tell you the last thing in the world that any of us thought would actually work is vertical launch and propulsive recovery of the first stage. I mean, we had ideas about separating out the engines or flyback, and I mean, just tons of different things. It was like, no, this won't work. And lo and behold, you had a group of folks that said, hey, I think this actually could work. And they were just determined, and they were beneficiary of a guy that had enough money that he didn't have to explain to somebody else why they should invest in it and the like. And so, but that to me is an example of they didn't know what they couldn't do, and they proved that they could.
That's great. Thanks.
I've got a quick question for you, if you don't mind. If you could do it all over again, I know it's a cliche, but would you stay in the government sector for as long as you did, or would you start in the government sector as opposed to the private sector?
So I guess the first question, I cannot possibly imagine having had a more fulfilling career and series of opportunities than what I had in the government. It's sort of unparalleled. I take a look at a lot of, I ended up my later years working with people, and it's been their 30 years plus in industry, and I had huge respect because they had a huge diversity of experience, and they had to make their numbers and be successful on the business side of things. But I take a look at my career, I can't fathom it. If you really enjoy the space business, the defense and national security and the rest of that, I mean, I absolutely wouldn't have changed a day of it. Now, having said that, I think there's a lot of opportunity advantage to be able to work back and forth between government and industry. It's one of those things that we don't do nearly enough of that. And in order for that partnership to work effectively, both sides have to make sure that they understand what makes the other part tick. There's a lot of people that look at government and say, oh, how ponderous and ineffective it is, and the like. But the fact of the matter is there's a lot of very talented people that have to navigate through some pretty bureaucratic situations, if you will. And you could say, well, gee, that's really hard, or that's stupid, or whatever. But the fact of the matter is that's the way the government operates. And the government has a lot of role in investing in advanced technology and capability. So, and in turn, there's a lot of things on the government side that are completely unmindful of what drives behavior when you actually have to make profits and to drive business and to satisfy investors and things like that. So I think I wouldn't say necessarily a perfect world, but I do think a big component needs to be how people can move back and forth between government and industry to really appreciate the symbiosis that needs to exist in that. And you just become a lot more effective partners if you understand each other and the sort of the world that they live in a lot better.
Thank you.
Yeah. Well, anything else? I know we're probably approaching the witching hour here, but I'm fine if you all are fine.
I have another question for you, if you don't mind. This one is, I guess, more specific to your time at Lockheed Martin. And I was just curious if you had like any involvement with like the inception of ULA with Boeing.
Did somebody put you up to that?
No, I was just curious.
Yeah. So my this wasn't during my time at Lockheed, but when it was decided that we no longer could really support two completely separate launch providers, and was actually involved in the creation of the evolved expendable launch vehicle program back in the early 1990s. And we had expectations about how the commercial market was going to grow, and there'd be enough demand to be able to support two distinct companies, one with the Atlas V and one with the Delta IV. But then those markets collapsed in the late 1990s, and it became apparent that we couldn't support two any longer with the government. But the trouble was, each one had its own benefits, and so you couldn't pick one or the other. So what we ended up doing is having to create a shotgun marriage between two rival companies that had fought hard for their respective launchers and the rest of that. Now all of a sudden we said, well, why don't you just create this joint venture and to figure out how do you consolidate engineering workforces and manufacturing and production and the like. And so part of the reason that you're getting a little bit of a long-winded answer, that later in my career, I was the individual that was supposed to figure out how are we going to actually mash these two companies together. It was sort of like the Hatfields and the McCoys. And it truly was a shotgun marriage. And so it was one of those things where in retrospect, you can say, well, why weren't we smarter about our dependence upon the commercial market carrying things? It was sort of a hopeful strategy that didn't work out. And then we ended up paying the price, and we didn't like what happened in terms of the cost of those launchers and the rest. And lo and behold, that then attracted new launch providers like SpaceX to try to come into the marketplace. But so big, we could probably talk for an hour of the history over the past 50 years of how hard and how in some cases misguided we were in terms of how the nation chose to actually develop and acquire our launches into space. I mean, I briefly touched on, we made a decision back in the Nixon administration in the 1970s that the space shuttle was going to become the sole means of access to space for all the nation. And then what ended up happening was we lost Challenger. And so we literally had to do a 180-degree reverse turn on that, because it said, well, wait a minute, we've got these critical national security payloads that we can't be standing down for 2 or 3 years. And oh, by the way, do you really want to have human crews on things that you're trying to get into space? Then we had other things with Atlas and Delta. So we've gone through some real trials and tribulations. And so I, for one, over my career, are hoping that we're getting to a point where I wouldn't say it becomes really routine, but that we make it far easier and more cost effective to get access to space, because that is the sine qua non of operating in space, is can you make it affordable and routine the access? But we haven't figured out how to repeal the rocket equation though. So that's the other part. All right, Josh, what do you think?
We had another quick question in the chat.
Okay.
It shouldn't be that long of an answer. Is there any specific kind of work when you're first getting into the field or still in college that's more beneficial than the other, in your opinion? Or do you have any advice on that?
So everybody's going to have kind of their own experience, but I will tell you, I think one of the things I benefited from was very early on. Of course, you get a degree in a particular engineering specialty, but very early on, I really had to learn about systems engineering because anything in one particular field connects to others and the rest of that. And so I thought that was very beneficial. Now, at that point in time, we didn't even really have degrees or curriculum in systems engineering. It was sort of a learned skill on the job, and that's the way I ended up doing it. So I had to start becoming proficient with electronics and understanding RF engineering and things like that. And you kind of had to learn it as you went along. But to me, those are very important skills. And frankly, that's, as I say, there are people that are really inclined to want to work over their career on technical things. You can become the expert in a particular phenomenology, technology, or whatever else. And trust me, people that do that are highly respected. Every major company out there has their senior people that are the revered experts. It's sort of like the oracle that you go to on these things. And in other cases, you have people that are really the highly respected systems engineers that understand how all the specialties and things come together. And then there are those that have gotten really good technical skills, but moved into program management. So if you take a look at sort of the top tier of people that spend 30 years and the rest of that. There's places for all of those kind of skills out there, and they're all very much mutually respected.
Awesome. Thank you. There are no more questions in the chat, so if anyone has any last minute questions, you can speak up. Otherwise, I think we might call it a night here.
Okay.
All right, well, I guess that's going to be all for tonight. Thank everyone for attending. Thank you, Mike, for taking the time to come and join us and talk to us.
Yep. Thank you for having me, and I only regret that we weren't able to do this face to face, because it's always better that way. But you'll keep up the great work, and I think you got great opportunities and futures ahead of you. So just keep your legs pumping.
Thank you. Have a good night.
Right.